Hello students, welcome to the class. This is second in series of the chapter surface areas and volumes. So today we'll learn surface area of a sphere. As a continuation, this covers CBSE and Karnataka state syllabus of 9th standard mathematics. In the last class, we studied how we can realize a cone from a right angle triangle. Okay, that means we realized a 3D object or a solid figure from the planar figure. Okay, now let's continue with the same the similar topic. Today let's understand how can we realize a sphere from a circle. See, sphere is a solid object, circle is a planar figure, right? So how can you do that? So what is circles then? Okay, circles are flat figures or planar figures in a plane where every point is the same distance from a center point. Okay, just look at it. Just imagine this is a circle and this is your center point, right? These are the points on the circle, correct? Okay, all these point circles. See, every point on the circle is at the same distance from the center. Okay, so then what is spheres then? What are spheres? See, spheres are 3D shapes where every point in a space, okay, is the same distance from the central point. See, for example, just think this is a point, okay, and some point on the surface, some point on the surface, some point on the surface, right? Every point on the surface of the sphere is at equal distance from the center of the sphere. Okay, then imagine rotating a circle. You can imagine a circle, right? Or you just imagine a coin also, your 2 rupees or 1 rupee coin. Imagine rotating a circle, okay, around its diameter, like spinning a coin, right? Yeah, the circle spins, it forms a shape, right? The center point remains the same, becoming the center of the sphere. So what is the takeaway? Key takeaway here: spheres are 3D versions of the circles, encompassing all points at a constant distance from the center. I think now it's very clear, right? How we moved from a planar figure to the solid figure. How we moved from the 2D shape to the 3D shape. How we moved from the circle to the sphere. Now let's do a small activity. Okay, have you ever played with the top? Are you aware of how string is wound around it? Definitely you need to wind the top to shoot it on the ground to make it play, right? The top to rotate, right? Okay, so this is just for your realization. Just you can imagine the top you played at home, or you play, or one we get to see in your the shops around you, right? Definitely the thread is not wound like this. Okay, now to start with an activity, get ready with a rubber ball, drive a small micronail into it, and be ready with a sheet of paper with a pen. Of course, you need a thread to wind the ball. Okay, now wind the string around the ball. Okay, you can take the help of a small micronail. Okay, starting from the nail and covering the entire surface, right? You can start from here like this, like this, like this, like this, like this. Okay, just I'm drawing bad the drawing, but imagine yourself. Okay, to ensure the neatness, use pins to hold the string in a place at the fullest part of the ball, and then continue it. You can use this string, the micronail to get the support. Okay, you can imagine this is how you are supposed to wind the string around the ball. Start from the this micronail and cover entire area till here. Okay, look at this no, the threads are not overlapping on each other. They're like perfect rectangles side by side. Okay, then once the ball is completely covered, mark the starting and ending points of the string. For example, this point and this point of the thread. Remember, your thread may be very long. Just mark starting and ending point of the thread, which perfectly covered, fully covered this area of the ball, surface area of the ball. Now measure the diameter of the ball, and if you don't know how to measure, take your teacher's help, somebody's help, right? Okay, measure the diameter of the ball. Okay, calculate the radius. Then what is radius? Radius is half of the diameter, right? Then draw 4 circles, like 1 2 3 4 on the paper with the same radius as the ball, right? How do you find the radius? Of course, this region, the kind of imagine equator region of the earth, the widest region, right? End to end part. Okay, so now you got a diameter and you make it off, you got a radius. With that radius, okay, draw 4 circles on your paper. Then compare. Lay the unwounded. See, you take out or unwind the string from the ball, right? Okay, so then what you need to do is lay the unwound string over the 4 circles that you drew on the paper. You should find that the string perfectly fills the 4 circle. Whatever the string here, it perfectly fills 4 circles. Then now we are seeing some formula being revealed. Now surface area of the sphere, right? It's 4 times the surface area of a circle. Okay, what is the surface area of a circle? Pi r square. Now what is the surface area of this sphere? Now it is simply 4 times, because the thread is perfectly filling the 4 circles. You can see the images, right? So what is the takeaway now? Is surface area of a sphere is 4 pi r square, where r is the radius of the circle. Now let's try to split this, the circle into, 2 hemispheres. Okay, spheres one face. See, sphere has one face, right? A single curved surface envelopes the entire sphere, correct? It has got only one face. Okay, we can't say where is beginning, where is ending. It's got a one single curved surface envelopes the entire sphere, correct? Then slice the sphere through its center, like this. You can see this. Either you can do this way or you do this way. Okay, just do one way, right? Imagine you're doing like this. Okay, now slice the sphere through its center. With plane creates 2 equal halves. Okay, called hemispheres. Now hemi means what? Half, right? Now once you slice it, becomes 2 halves. Like this, you can see again, imagine yourself. Okay, so that these 2 halves are equal halves, and we call them as a hemispheres, because sphere, one full sphere became 2 half spheres. Okay, we call it as hemispheres. Okay, hemi means half. Okay, okay, each hemisphere has 2 faces. Remember, each hemisphere, see, there's one hemisphere, 2 hemisphere, right? It has got 2 faces. For example, in the upper hemisphere, you got this is 1A and this is 2, correct? Similarly here, this is one curved surface and this is flat surface, right? Each hemisphere has 2 faces. Okay, so the same curved surface as original sphere. First curved surface is the same as the original sphere, but just half the size, correct? The whole thing now become this curved surface, right? It is same as the original sphere, but half of its size. It's very much. Then the second part, right? This region. the flat surface, right? Newly created flat surface from the slide, the slice. So you got it, right? The hemisphere has got now two faces. The sphere has got only one face. Now the hemisphere has got two faces. Okay, the two faces are, one is curved face, one is a flat face. Okay, flat base. The curved surface area is half of the sphere's area, correct? Then half of space. Okay, what is 4 pi r square is surface area, right, of a sphere. Then divide by 2. 2 ones are 2 twos are. So 2 pi r square. So half of the sphere surface area is how much? 2 pi r square, where r is the radius. Then flat base. See, flat base is circular, correct? And its surface area is, of course, area of circle, which is pi r square. Now sum them up. Total surface area is equal to sum of the surface area of the curved surface and flat base, which is equal to 2 pi r square, curved surface area, and pi r square. Okay, flat surface area, which is equal to 2 pi r square plus pi r square is equal to 3 pi r square. Clear? Now what is the takeaway? Takeaway is simple, right? Curved surface area is equal to 2 pi r square, curved surface area outside. Okay, and we are talking about hemisphere, remember, not the sphere. And flat surface area is equal to pi r square, this region. Okay, and total pi r square is equal to sum of these two, right? Is 2 pi r square plus pi r square, 3 pi r square. This is a takeaway. Okay, total surface area TSA is equal to 3 pi r square. Okay, now let's try to understand the sphere, surface area of the sphere, by going through a couple of the numerical examples. Okay, the first one now we are seeing is find the surface area of the sphere of radius 7 centimeter. Correct. So now, as usual, we go with what is given at data and then we get into solution, right? What is given here first is the radius is 7 centimeter. We note it down here. R is equal to 7 centimeter. And just visualization. Okay, this is a sphere with radius equal to 7 centimeter. Okay, what is surface area then? We need to find the surface area. That's the the objective of this problem. I mean, this is what solution required. Now let's get into solution now. What is surface area of a sphere? Surface of a sphere is equal to, I mentioned, okay, surface area of the sphere is equal to 4 times the area of the circle. It means 4 pi r square, correct? 4 times the area of the circle. And then area is equal to how much? 4 into pi, I can note it as 22 by 7. Then r square is equal to r into r, that is 7 into 7. This r, I'm putting it here, radius. Okay, of course 7 gets cancelled. Next 4 is 4 into 22 into 7, correct? So that is equal to how much? 88 into 7. That is equal to how much? The surface area of a sphere now is equal to, if you multiply 7 8s are 56, like that. If you get surface area of the sphere is equal to 616 centimeter square. Remember, centimeter square. Area, unit of area is centimeter square. Okay, now let's try to solve one more numerical another problem. Okay, let's find the curved surface area. Remember, curved surface area and the total surface area of a hemisphere of radius 21. Now we are no more doing dealing with full sphere. We are dealing with hemisphere here. Okay, and what is the radius of the hemisphere? 21 centimeter. Now as usual, start with given. What is given? Radius of a hemisphere is 21 centimeter. It's given here. And what we need to find? We need to find the total surface area. Okay, and of course area of this hemisphere. Oh, sorry, curved surface area. Total surface area and curved surface area you need to find out, correct? Okay, then let's get into solution now. Okay, now you see we pi r square, let's calculate its area of the circle, because we might be using again and again. Of course they did not ask us. Okay, what is pi r square? It says area of circle, right? That is equal to how much? 22 by 7 pi into r square, 21 into r 21. So now 7 ones are 7 threes are correct. So now 22, okay, and 3 into 21 it becomes. What is the answer now? That is equal to 22 into 63, these things. And that is equal to 1386 centimeter square. This is the area of the circle. Clear, right? Now coming to the actual problem, this one, curved surface area. The curved surface area of a hemisphere is equal to 2 pi r square, right? Twice the radius of the circle. We learnt it. Okay. So simple. We already know it. Multiply with 2. Otherwise, we go as usual, right? So how much? 2 into 22 by 7, 2 pi r square, r into r. Okay. So 44, 22 into 22, 44. So 7 3s are 31, 21. So then 3 and then 21. That is equal to how much? 132 into 21. These two. Okay. That is equal to 2772 centimeter square. Instead of doing all these works, right, you can simply say multiply it with 2. Simple. Correct. That's the reason I calculated this pi r square, though they did not ask. Okay. What is second thing? What is that they asked? They asked total surface area, right? What is total surface area? Is sum of the total surface area of the curved surface and the surface area of the flat base, circular base. Correct. Then what is the formula? 3 pi r square. Correct. We learned it. So it means 3 times the the area of the circle, which is we already calculated here, right? 3 times of that. That is equal to 3 into 22 by 7 pi into 21 into 21 r into r. Correct. As usual, you simply multiply 3 into this one. That's also good. Or 3 into pi r square. That is equal to 4158 centimeters square. Then what is the answer now? The answer is the curved surface area, the first one, right, is curved surface area of the hemisphere is 2772 centimeters square, and the total surface area of the hemisphere is 4158 centimeters square. Okay, then let's do one more numerical. Let's try to solve one more numerical problem example. The hollow sphere, you remember the sphere is hollow now. Hollow sphere in which circus motorcyclist performs stunts. I'll show you an image also for helping to look at it. Just imagine something like this: hollow sphere in which the circus motorcyclist performs his stunts as a diameter of 7 meters. So it means what is the diameter of this entire edge is 7 meter diameter. Of course, it means radius is half of it. Find the area of the given the area available for the motorcyclist to riding. What is the area? This is the area, right? Circle. You will be doing it inside it. Okay. What is the area available for the motorcyclist for riding? Okay. Let's go with start with given. What is given? Diameter of the sphere is given 7 centimeter. Then we need a radius. Of course, radius is equal to diameter by 2. That is 7 by 2. That is equal to 3.5 centimeter. Then solution. Let's start with solution now. So the riding space means inside space available for the motorcyclist is surface area of the sphere, correct? Assuming it is the thickness is negligible, the space riding space available for the motorcyclist is equal to surface area of the sphere, correct? You will be doing all the stunts inside the entire surface area, right? Entire surface area. Then then what? Surface area of the sphere is equal to how much? 4 times the area of the circle, that is 4 pi r square. How much? 4 into 22 by 7 pi, okay, into 3.5 into 3.5. Now what is 7 ones are? 7 5s are, correct? This one, but 0.5, remember, okay? Okay, 0.5. What is the value? 22 into 2, 22 into 4, 88 into 0.5 into 3.5 as it is. That is equal to 88 into 0.5, how much? 44 into 3.5. That is equal to 154 meters square. This is the surface area of the sphere. Though the area available to the motorcyclist for riding is, of course, this is entire surface area is available for him, which is 154 meters square. This is an answer. Okay, let's take one more example, a numerical example, and solve it. Now we are talking about hemisphere, remember. Hemispherical dome of a building. Hemispherical dome of a building needs to be painted. Okay. If the circumference of the base of the dome is 17.6 centimeter, let me take an example. Imagine, okay. Just it will give you imagine. Hemispherical dome of a building needs to be painted. See this hemispherical dome. Okay, this region. Okay, so you can also imagine this way. Okay, if the circumference of the base of the dome is 17.6, assuming it's exactly same. Okay, and this is circular in nature. Okay, this entire region is circular, like you can see this image, it's a circular, in base is circular, right? Okay, if the circumference of the base of the dome is 17.6 meter, find the cost of the painting. Given the cost of the painting is 5 rupees per 100 centimeters square. Okay, let's solve it. First let's understand it. What is given there? What is given? Only the rounded surface of the dome is to be painted. Recall it. Only this has to be painted. Only this has to be painted. Not this is not required. Okay, this entire region is not required, right? Only the rounded surface of the dome is to be painted. It means it's okay for us to calculate the area of this, the rounded surface, right? We would need to find the curved surface area of this hemisphere because that's what going to be painted. Then what is circumference of the dome? It's given, right? Circumference of the circumference of the base is given, right? What is that? 17.6 meters. Then we need to calculate the radius out of it, okay, of the dome, because we need radius for our calculating surface areas, correct? See, before that, let's see, observe this point. Remember to keep always the same units. Okay, you can do it later also, this portion, but I'm showing it now. Look at it. What is the unit of the circumference? Meter. The circumference is in meter, but the painting cost is given in centimeter square. Either you convert this into the centimeter or you convert this into the meter. You can do both. But now in our case, let's continue with meter as a unit. Okay, so it means we need to convert this centimeter square. We need to convert this centimeter square into meter square, because area is unit of area is unit square, that's meter square, right? What is, we know, correct? 1 centimeter is equal to 0.01 meter, we know that. Okay, then 1 centimeter square is equal to how much? Because we are interested in the area of the unit. It's a area, right? It means the unit is square unit, correct? Unit square or square unit, correct? So then what is this? 1 meter square is interested, right? The square both sides. It means 0.01 into 0.01, of course, meter square. Okay, because we are squaring both sides. This is square and this is square. Then what is that? Solve it. 0.01 into 0.01, how much? It is 0.401. 0001. That's the correct answer. 3 zeros, remember. Okay. Then what is that we are interested? It's given here 100 centimeter square is the area. 5 rupees, cost is 5 rupees per 100 centimeter square, right? I also want to know what is 100 centimeter square in terms of meter square. Naturally, you multiply, see, 1 centimeter square is equal to this much meter square, right? Multiply with 100, that is equal to 100 centimeter square. How much is that? You remove 2 zeros here. That is equal to 0.01 meter square. Now it is very clear, right? So it means the cost of the painting is rupees 5. Cost of the painting is rupees 5 per 0.01 meter square. It's very clear now. Now units are same. Okay, let's get into the solution. What is solution now? Okay, circumference of the dome is given. Circumference of the dome is given. What is circumference of the dome? That is equal to 2 pi r, correct? Circumference of the dome is equal to 2 pi r. How much? Circumference is given. So C is given to 2017.6 is equal to 2 pi and r. Now we can calculate, the r. Okay. So r is equal to how much? 7 comes this way. So 17.6 into 7, and 2 into 22 comes down. Okay, because after cross multiplication, right? R is equal to 17.6 into 7 divided by 2 into 22. That is equal to, if we solve it, it will become 2.8 meters. Okay, It's clear now, right? So now we got a radius of it. Now what is the radius of circle? You can calculate pi r square, right? But let's go directly into 2 pi r square. You know that, right? Curved surface area is equal to how much? We know that curved surface area is of the dome is like, assume itself is a hemisphere, correct? What is the, curved surface area of the hemisphere is equal to half of the total surface area of sphere, right? That is 2 pi r square now. So curved surface area of the dome is equal to 2 pi r square. Alright, let's substitute. Okay, is equal to 2 into pi, 22 by 7 into 2.8 into 2.8, of course r into r. That is equal to how much? 22 into 2, 44. 7 fours are 2.8, so 0.4 into 2 as it is. That is equal to 17.6 into 2.8. These two are 17.6, 2.8. Okay, that is equal to how much? 49.28, 49.28, 49.28 meter square. Now we got CSA, total curved surface area of the dome. That's what we were going to paint it, correct? Yeah, 49.28 square. Now let's go for calculating the paint cost. We got an area now, area to be painted, okay, which is, so no, the curved surface area. Now cost of the paint, right? Cost of the painting, this given here, right? What is there given? To the cost of painting 100 centimeter square surface area is equal to 5 rupees 5, correct? Now let's change the unit, okay, to meter square. So the cost of the painting 0.01 meter square, because we proved it here, correct? So 100, okay, it means cost of painting 0.01 meter square surface area is equal to rupees 5. Now what is 1 meter square? Then what is the cost of painting 1 meter square surface area? That is equal to 5 divided by this 0.01, right? 5 divided by 0.01, how much? 500 rupees. Okay, now let's continue. Okay, so how much? The cost of painting 1 meter square is rupees 500. We got it. Therefore, the cost of painting the whole dome is the painting cost per square meter into the surface area. That is rupees 500 into surface area. Okay, that is equal to rupees 24,640 rupees. That is the cost of the painting the entire dome. That's an answer. Now, yep, let's stop it here now, because we covered the surface area of the sphere, and continue the next topic in the other session. Thank you.